All right, we've all been there, right? You ask an AI a question, and what you get back is this super confident, really well written, and totally wrong answer. It's a massive problem. So how do we fix it? Well, today we're going to look at a really clever solution called Retrieval Augmented Generation, or RAG for short.
So let's just start with a simple but absolutely crucial truth. Large language models are incredibly smart, but they can lie. Not on purpose, of course, but they have this tendency to invent facts, dates, and even product features just out of thin air. In the industry, this is called hallucination, and it's a huge, huge problem when you actually need reliable answers.
So what's really causing this, let's call it a reality problem? Honestly, it's pretty simple. An AI's knowledge is basically frozen in time. It only knows what it was taught from its training data. That means it has no clue about yesterday's news, and it definitely has not read your company's private internal documents. And that knowledge gap, that's where the made-up answers come from.
And this really gets to the heart of the solution. You see, a standard LLM over on the left is basically just guessing. It might invent a product feature because, hey, it sounds like it could be real. But a system powered by RAG on the right, it doesn't guess. It looks up the answer in an official manual and gives you the verified fact, complete with a source. It's the difference between a total guess and a rock-solid guarantee.
So how do we get from that wild guess to a verifiable fact? The solution is this powerful but surprisingly elegant concept, Retrieval Augmented Generation. And honestly, the easiest way to get it is with a simple analogy. Just imagine we're giving the AI two new partners, a super efficient librarian and a very disciplined author.
So here's how this little team works. First up, you've got the librarian, or what the system technically calls the retriever. Its one and only job is to search through a trusted library of documents to find info that's relevant to your question. Then you've got the author. That's the language model. Its job is to write an answer using only the facts the librarian handed it. No outside knowledge, no making stuff up, period.
It's a great concept, right? But how does this machine actually work under the hood? Let's pull back the curtain on the analogy and look at the three main technical phases that make this whole thing possible.
So let's start with phase one, building the library. You see, before the AI can answer a single question, we have to give it a high-quality, trusted set of books to read from. This is the foundation for the entire system. You got to get this part right.
This preparation process is absolutely key. First, we ingest all our trusted documents. Think PDFs, websites, you name it. Then, because you can't just feed an entire textbook to an AI at once, we break those documents down into smaller, bite-sized chunks. Next up is the really cool part. We convert these text chunks into a series of numbers, which we call embeddings. You can just think of an embedding as a set of coordinates on a giant map of meaning. Things with similar meanings, they're located really close together on this map. Finally, we organize all these coordinates in a special database called a vector store, which is built to find the closest meaning at lightning speed.
Now, this brings up a really important question for the engineers building these systems. When we're chopping up those documents, how big should each page or chunk of text actually be?
And this right here reveals one of the biggest challenges in building a RAG system. If you make the chunks too small, they're super easy to search for specific facts, but you risk losing the context that surrounds that fact. On the flip side, if the chunks are too big, you keep all the context, but you might be feeding the AI a bunch of irrelevant noise that just confuses it. Finding that perfect sweet spot is really part of the art of making these systems work well.
Okay, so our library is built. Now we can move on to phase two, finding the facts. It's time for our librarian to get to work.
This happens in two super quick steps. First is what's called semantic search. Your question gets turned into one of those numerical embeddings too, its own coordinate on the map. The system then zips through the vector store to find the text chunks whose coordinates are closest to your questions. This means it's not just matching keywords, it's searching for similar meaning. But it doesn't stop there. The system then re-ranks those results using an even smarter model to make sure the absolute best, most relevant info gets pushed right to the top.
And that leads us to the grand finale, phase three, writing the answer. This is where the author, our LLM, steps in to craft that final response you're waiting for.
So here's where it all comes together. We build a really specific, powerful prompt for the AI. This prompt contains two things: your original question and the top-ranked facts that our librarian just found. We're basically telling the AI, hey, answer this question, but you must use only these verified facts to do it.
And boom, this is the result. The
The AI gives you a clear, concise answer, but, and this is the best part, look closely, it includes citations. It tells you exactly where it got every piece of information, linking right back to the source documents. This isn't just an answer anymore, it's a verifiable, trustworthy piece of information. So when you put this all together, what have we actually built here? We've essentially given the AI its own personal, built-in fact checker. It's no longer just speaking from memory. It's required to look things up in a trusted source before it says anything. So why is this whole technique such a game changer? Well, because it completely changes how the AI behaves. By grounding it in facts, we slash the number of hallucinations. We can feed it constantly updated knowledge, turning it into an expert on literally any topic we want. And by providing those citations, we create a system that isn't just smart, it's trustworthy. This is how we make AI safe and reliable enough for the real world.
And that leaves us with a pretty fascinating thought to end on. If even our most advanced AI needs an external library just to stay truthful, what does that really tell us about the nature of intelligence itself? Maybe being smart isn't just about what's in your head, but also knowing exactly where to look for the answer. Something to